You are looking live at Trig Identities. What I'm going to do is I'm going to simplify Trig Identities for you here. So this will be some practice with that. So in my first part, we want to simplify tangent theta. So tangent theta by the quotient identities, that is going to equal the sine of theta divided by the cosine of theta. Okay? Cotangent theta. Cotangent theta is the reciprocal of the tangent theta, so this is just going to be cosine theta divided by sine theta. Okay? Now, cosecant theta. Cosecant theta is the reciprocal of the sine, so we can write that as 1 divided by sine theta. And secant theta is reciprocal of the cosine, so that's going to be 1 divided by cosine theta. All right, so we're going to use these a lot as we're simplifying trig identities along with the Pythagorean identities, which we're going to start here. Okay, so what do we know about the Pythagorean identity? Well, the Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. So in my first problem here, what we're going to do is we're going to solve for the Pythagorean identity for cosine squared theta. All right. And so this is a common thing that students miss. And a lot of times what's going to happen is we're going to sub in. So if I solve for cosine squared theta, that's going to be equal to 1 minus sine squared theta. And this is one that a lot of students miss because they're unsure of that you can manipulate this and use that in your simplifying. Okay. And then we also have solved the Pythagorean identity for sine squared theta. Well, again, we can, if we had, that would be the same thing as sine squared theta is equal to 1 minus cosine squared theta. So you have the ability to manipulate that Pythagorean identity in order to solve that. Okay? So in this next part here, we want to take the Pythagorean identity and we want to divide every single term by cosine squared theta. So what would we do for this? Well, if we divide every single term by cosine squared theta, we're going to come up with some new Pythagorean identities that we can use. Okay, so if we look at this here, we divide everything by cosine squared theta, and then that would equal 1 plus, and then sine divided by cosine is tangent, so this would be 1 plus tangent squared theta is equal to 1 over cosine squared, which is going to be secant squared theta. So by a little manipulation of Pythagorean identity, you can come up with another identity to use. Okay? So now it says solve this for tangent squared theta above. Well, what we would do is we would get tangent squared theta is equal to secant squared theta minus 1. So again, these are some other things that you can use when you are simplifying trig identities. All right, same thing here. We're going to divide now by sine squared theta, come up with another identity. So if I divide everything by sine squared theta, I would get cosine over sine cotangent, so I get cotangent squared theta plus sine squared theta divided by sine squared theta is 1, is equal to 1 over sine squared theta, and that would be the same thing as cosecant squared theta. So again, we have another identity that we can use, and then we can manipulate this to, if we need to replace the cotangent squared. So the cotangent squared theta is equal to cosecant squared theta minus 1. So that's another one that we can use on there. Okay, some other identities that we're going to use. sine theta, not as common to use, but you can replace this by 1 over cosecant theta, and we see that at the bottom in our chart there. Same thing with cosine theta, its reciprocal identity is 1 over secant theta. Oops, not squared, just 1 over secant theta. And then tangent theta is 1 over cotangent theta. So those are some of our reciprocal identities. Okay, so let's use these now. So we basically have the ability to use all these. So one common thing that I try to teach my students is that if you see squareds inside your expression, you're probably going to either do some factoring or you're going to use one of the Pythagorean identities. If you don't see any squareds in it, they're all to the first power, you're probably going to do some replacement with some of your quotient identities, some of your reciprocal identities. Okay, so let's look at some of the problems that we have here. All right, so in example 1A, we have, so example 1 says we want to use the trigonometric identities to write each expression in terms of a single trigonometric identity or constant. Okay, so we want to get it down to a single one. So we have tangent theta times cosine theta. So again, I don't see any squares in this, so I'm probably not going to use the Pythagorean identity, but what I see is I see tangent here. So what I'm going to do is I'm going to replace tangent by sine theta over cosine theta. And if I multiply that by cosine theta, what's going to happen? Well, our cosines are going to cancel. So this is going to simplify to sine theta for this one. All right. Okay, so in part B, I start to see some squares here. And if I look at the top here, I can see that that is a manipulation of the Pythagorean identity, and that's actually equal to sine squared theta. And if I divide that by cosine squared theta, sine over cosine is a quotient identity for tangent, so this would simplify to tangent squared theta. Another thing I want to mention is that a lot of students don't realize that if it's squared or to the power, if they're the same, you can still use the identity. You would just put the squared in. So again, sine theta over cosine theta is tangent theta. If we square both of them, we can just use that square in our identity, okay, as long as they're both to the same power. All right? Okay, in our next problem, we have cosine theta times cosecant theta, and we want to simplify that. Well, I see here that I don't have a squared, so I'm probably going to use some type of replacement with either quotient identity or reciprocal identity. So I see cosine theta, and cosecant theta is 1 over sine theta. Well, what is that equal to? That's equal to cosine theta divided by sine theta, and that is equal to the cotangent theta when I get it down to a single identity. All right? All right, next problem. I see the top that I have sine theta times secant theta. So what I'm going to do is I'm going to replace secant theta by 1 over cosine theta. So I get sine theta times 1 over cosine theta, all divided by tangent theta. Well, the numerator is sine over cosine, and that equals tangent. So I got tangent theta divided by tangent theta. So tangent theta divided by tangent theta is equal to 1. And we've simplified that down to a constant or a single expression. Okay, in the next part here, we are going to simplify the complex fractions. And the reason we're doing that is we're going to use that in the next section when we simplify. So the technique is going to be the same that we would do with numbers as we would do with our expressions. So for example, here we have 2/3 times 4/15. Well, when you divide by a fraction, you have to multiply by the reciprocal. And if we cross cancel here, 3 into 15, 5, 2 into 4, 2, we get 5 divided by 2. Okay? Same thing in the next one. This would be 4/5 times the reciprocal of 4/35, which would be 35 over 4. Hi, how you doing, Adam? And then we would cross cancel. That would equal 1, so we would get 7 as our answer. Okay? All right. So carrying on with this, let's do a few more of these. 2/5, so the reciprocal would be 5/3. So this would reduce down to 2/3 when we multiply it. And in the last one, we have 1/2 divided by 2 whole, so that would be multiplying by the reciprocal. So we would get 1/4, that's our answer. So why are we doing that? Well, we're doing that because you're going to use that in the next section. Right? We're going to get some complex fractions that we have to simplify. So for example, in 3a, we have cosecant theta divided by cotangent theta. So what we need to do is, again, we're going to replace the top with its reciprocal identity. So we would get 1 over sine theta, and the denominator is the cotangent, which is cosine theta divided by sine theta. And if we multiply by the reciprocal, what we would get is 1 over sine theta times the reciprocal of this would be sine theta over cosine theta. And then my sines would cancel, so I would get 1 over cosine theta, which is equal to the secant of theta. Okay, so again, we're using the techniques that we did above in order to simplify that. All right, in part B, 1 minus cosine squared, that is Pythagorean identity manipulated, so that would be sine squared. The denominator is tangent squared, which is sine squared divided by cosine squared theta. And if I multiply by the reciprocal, I get sine squared theta times cosine squared theta over sine squared theta. These would cancel, and I would get cosine squared theta as my answer here. Okay? All right, so let's continue with this. If we had cosine times secant, we would get, secant is 1 over cosine, so we get cosine theta times 1 over cosine theta divided by the tangent of theta is sine over cosine. Well, cosine divided by cosine is 1, so I have 1 over sine theta divided by cosine theta, and that's the tangent of theta. So I have 1 over tangent theta, and that is the reciprocal of the tangent, which would be the cotangent theta as our answer there. All right, so in the last one, we've got sine theta divided by cosecant theta. So I'm going to replace cosecant theta with 1 over sine. So I got sine theta up top. I got 1 over sine theta in the denominator. And if I multiply by the reciprocal, I would get sine theta times sine theta. So I would get sine squared theta. All right? Okay, so that would be an example of using some complex fractions in order to simplify, where you have fractions in the top and the bottom. Okay, so let's see if we have some more. All right, so let's try some day 2 examples here. Okay, so what happens if this gets a little more complicated here? Well, if we look at example 1a, what's happening is that we have tangent theta plus cotangent theta over tangent theta. Well, the first thing we would want to do is they both share a common denominator. If they share a common denominator, what you can do is you can split that up. into separate terms. So that would be tangent theta divided by tangent theta plus cotangent theta divided by tangent theta. Okay. And then what happens in this case here? Well, tangent theta divided by tangent theta is equal to 1. The cotangent theta divided by tangent theta, let's do that on the side here. So cotangent would be cosine theta over sine theta, and tangent is sine over cosine. If you multiply by the reciprocal, you're going to get cosine squared theta divided by sine squared theta, which is equal to the cotangent squared theta. Because we have cosine over sine, which is cotangent, but we're squaring it. So this would be cotangent squared theta. Now, what does that equal? Well, if we go back to our manipulation of the Pythagorean identities, the cotangent squared theta are 1, let's see, what was it again? It was 1 plus cotangent squared theta. If we go back and look, 1 plus cotangent squared theta is right here, and that's equal to the cosecant squared theta. Okay? Whoop. So this would equal the cosecant squared theta. All right? Okay, so let's look at example B here. Now, this is a common mistake. A lot of students with this right here will replace that by cosine theta, thinking it's part of the Pythagorean identities. Remember, the Pythagorean identities, it has to be squared in order to replace it. So it would have to be 1 minus sine squared theta in order to replace with cosine squared. So you can't do that. So actually what's happening here is we have to use the top, and we're going to replace cosine squared with 1 minus sine squared theta divided by the denominator 1 minus sine theta. And then what we're going to do is we're going to factor the top. So that would be a difference of squares. So that would be 1 minus sine theta times 1 plus sine theta divided by my denominator 1 minus sine theta. These would cancel, and I would be left with 1 plus sine theta as my answer there. Okay? All right. So what can we do in part C? Well, in part C, we can either do what we did in part A, since it's a single denominator, and split it up, or what we can do is we can look and see if this is a Pythagorean identity and see if we can replace that. So secant squared theta minus 1, if I go back, secant squared theta minus 1, secant squared theta minus 1 is equal to tangent squared theta. Okay. All right, so let's go back. Oop. So this is equal to tangent squared theta divided by secant squared theta. And in this case here, tangent squared theta is sine squared theta divided by cosine squared theta, and secant squared is 1 over cosine squared theta. If I multiply by the reciprocal, the cosine squareds are going to cancel. So we would get sine squared theta over cosine squared theta times cosine squared theta over 1. These are going to cancel, and I'm left with sine squared theta. Okay? All right, I'm going to stop at part D. So I don't see squareds in here, so let's replace. So tangent theta is sine theta over cosine theta. Cosecant theta is 1 over sine theta, and cosine theta is here. So if I look, sine theta are going to cancel, cosine thetas are going to cancel, so my answer here is 1. Okay, I hope this helps somebody out there simplifying trig identities. Please follow me if you liked the video here or you're watching it live, and thanks for watching.